Here we have chapter 3, principles 10, and motion in 2 dimensions. The arrow, the vector arrow, shows how far 0 from P is in magnitude and the direction of P. And then order P is the displacement vector, and name as the position vector. So here we go, this is the vector, this is the direction or magnitude, O to P, and then the degree of it. We have adding vectors. So here we have our initial, the difference, and this is the sum of it. So as it says here, scalar quantities, the mass does not have direction, but magnitude has. Does not have direction, but magnitude has position, and there's a vector that has magnitude and direction. A vector needs a magnitude and direction. So here we have velocity, force, and acceleration are magnitudes. Are vectors. And in this example, 0 to P, P to Q is the sum of 0 to Q. Here we have the parallelogram. So the parallelogram rule, where all the arrows have to go in the same way. So A and B create C. See how all the arrows go in the same way. Here it says it here. Also here, A, B makes C vector the whole entire way. A and B here are equal to 0, and so is here. So A, B, C, and then to D is equal to 0. I'm multiplying a vector. Here's R and R. So just to show you, this was just R, and 2R is double this vector. Here you go. Right? And then also in the negative direction, negative I direction. And here we go as well. If you multiply it by -1, you just get it going in the opposite direction. Here's it multiplied by -2. We also have subtracting vectors. So you have R2 minus R1 makes X. So here you go. R1 plus X. The R1 vector plus X vector equals R2. And you can simplify it to what this equals. And then it goes from the head to head when existing vectors share the same tail. So R1, R2 goes from the head of R1 to the head of R2. Here we have R1, R2. This is R2 minus R1, sorry. We also have vectors in physics where magnitude of velocity does not change, but direction of velocity changes. And then there is acceleration. So V initial, VF, V final, 5 meters per second. 5 meters per second makes delta V, which is their sum. And then we have the acceleration vector is equal to the velocity over time, and velocity is position over time. Here we have an example. And then we have vector acceleration, where acceleration is parallel to delta V. Here you have it. We have V initial, V final. This is the change in velocity, which is delta V, displacement. Right. And so this is another example. And that's the end of Principles 10.